Okay, the following diagram shows part of the curve of the function f. A, B, C, D, E lie on the curve. B is a min, D is a max. Complete the following table, noting whether the gradient is positive, negative, or zero at the given points. So at A, it's negative because it's going down. B is zero because it's a minimum. And E is also negative. And then we need whether the second derivative is positive, negative, or zero at A. So it's concave up there. Same at C, it's positive. And at E, it's concave down. All right, so now we have to complete the table noting, okay, so at 0, the function is positive because it's above the x-axis. The gradient is positive because it's going up there. And the second derivative at 0 is negative because it's concave down. Write down the number of inflection points. We have 1 here. Okay, we have this curve. Part of the graph is shown. There's a max at M and a point of inflection at N. Find the derivative. So we have, it's 3 times the third, which is 1x squared plus 4x minus 5. That's A. B, find the x coordinate of M. So we need to factor this thing and set it equal to 0 because we need a max or min, so we find the critical points by setting the derivative equal to 0. So this factors to this, and we're going to have at x equals negative 5, which is our x coordinate of M, and x equals 1 would be the x coordinate of this minimum. Okay. The x coordinate of N, that's an inflection point, so we need the second derivative, which is going to be 2x plus 4, and we set that equal to 0, so that's at x equals negative 2. D, the line L is tangent to the curve of f at 3, 12. Find the equation of L. Okay, so we want the derivative at 3, and we've got the point 3, 12. So the derivative at 3 is 3 squared plus 4 times 3 minus 5. So we've got 21 minus 5 is 16. So we're going to have y minus y1, which is 12, the point, equals m x minus x1, and then we can distribute the 16 and add 12. So in y equals mx plus b form, we have this. So 15, g at x is that. Find 2 values of x at which the tangent is horizontal. So that means we need to find the derivative and set it equal to 0. So we've got 3x squared minus 6x minus 9 equals 0. Factor out a 3. And then factor, and this is factoring to minus 3 plus 1. So these are the 2 values of x for which the tangent of the graph is horizontal. And for b, so to determine whether they're max or min, we can do the second derivative, which is going to be 6x minus 6. And then when we sub in 3, we get 18 minus 6, which is 12, greater than 0. So that means it's concave up. So x equals 3 is a min. And if we do the second derivative at negative 1, we're going to have negative 12, which is less than 0, which is concave down. So x equals negative 1 is a max. 16, that's the derivative. There's 2 points of inflection on the graph. Write down the x coordinate. So we need second derivative. So that's negative 72x squared plus 18x plus 3, and set that equal to 0. And since we can use a graphing calculator, I'm going to use that. So if we go to the calculate screen and menu, algebra, polynomial tools, find roots of polynomial. You've got, it's quadratic, so degree 2 real, and you just type in your coefficients, negative 72, 18, and 3, and you get that x is negative 0.114 and 0.364. Those are the two values of x for which there's an inflection point. Now g equals double prime. So this is g. Explain why the graph of g has no points of inflection. So if we did g prime, we'd get negative 144x plus 18, and then g double prime is negative 144. And that's never equal to 0. And remember, we have an inflection point when the second derivative is equal to 0. So that's why there's no points of inflection. Okay, so 17, consider this function. The graph has a vertical horizontal asymptote. So for A, the equation of the asymptotes, so the vertical is going to be, since it's same degree, we have the coefficients. So y equals 3 over 2, and x is going to equal, when the denominator is 0, and that's at negative 5 over 2. Just set 2x plus 5 equals to 0 and solve. So for B, find the first derivative, simplifying the answer as much as possible. So we have v on the bottom and the top. So we're going to have v times the derivative of u minus u times the derivative of v. So we can distribute. So we're going to have 6x plus 15 minus 6x plus 4, because that's a negative 2 distributed. So that cancels. So we're going to have 15 plus 4, 19 rather, over 2x plus 5 squared. Okay, so now C, write down the number of stationary points on this graph. So if that's the derivative, we would set that equal to 0. And yeah, that when you cross multiply, 19 doesn't equal 0, so there are 0 points, stationary points. Okay? And for D, write down the number of points of inflection. Well, if we find the derivative of that, you're still, okay, so it's going to be, so if we do like this, and we find the derivative of that, so that's negative 38, 2x plus 5 to the negative 3 times 2. So you're going to have negative 76 over 2x plus 5 to the third power. That's the second derivative. We set that equal to 0. When you cross multiply, again, negative 76 isn't 0. Inflection points happen when the second derivative is equal to 0, which is never happening. So no 0 points of inflection. All right, we have the first derivative. Find the second derivative. Is 3x minus 3 squared. Chain rule, you just multiply by 1. So if we do the derivative at 3, that's 3 minus 3. 0 cubed is 0. The second derivative at 3 is also 0. Explain why point P on the graph with x-coordinate 3 is not a point of inflection. So if we set this, okay, so if we set that equal to 0, we have, yeah, we would get x equals 3, okay? But then you need to test on either side. So x is 2 and x is 4, and you see that they're both going to be positive. So because it doesn't change concavity, it's not a point of inflection. 19, the diagram below shows this graph. There are points of inflection at A and C, and there's a max at B, using the product rule for differentiation. Okay, so A, first derivative, we're going to have the first times the derivative of the second. So that's the derivative of e to the x is e to the x times -1 because of the chain rule. All right, then, so that's the first times the derivative of the second. Now we have the derivative of the first times the second, so that's A. B, find the exact value of the y coordinate of B. Okay, so we are going to have negative x squared e to the negative x. This is the first derivative, plus 2x e to the negative x. We want to set that equal to 0 because that's going to give us the x coordinate of the maximum or, stationary point. Okay, so we can factor out e to the negative x. We can factor out an x, and that's it. So we're going to have a negative x here to get the negative x squared e to the negative x. And here we have plus 2. So this bit is never going to be 0. I guess actually it would be. It would be x is 0. Okay? But, yeah, they don't actually care about that. This one is going to be at x is 2. That's the x coordinate of B. And now we need to substitute in 2 to find the y coordinate B. So we're going to have 2 squared e to the negative 2, so 4 over e squared. That's the exact value. So for CI, show the derivatives that, So we have, so this is the first derivative here. I've simplified it. So I'm going to use, So you can do what you want to do here. You have to use a little bit. So if we do x e to the negative x is our u, and our v is negative x plus 2. du is going to be product rule. So it's the first times the derivative of the second. That's a negative out there. Plus the derivative of the first, which is 1 times the second. So I'll deal with that later. And then dv is just -1. Okay? So second derivative is going to be u times dv, which is just negative x e to the negative x, plus v times du. And we have to, we can actually easily, so here, whatever. So we have plus negative x plus 2. From here, I'm going to factor out an e to the negative x. On the inside is negative x plus 1. So now I've got e to the x that I can factor out. And on the inside, we're going to have negative x plus negative x plus 2, negative x plus 1, and then that e to the negative x is on the outside, and then we're going to have negative x plus x squared minus x minus 2x plus 2. So, and we're going to have x squared, and then we're going to have negative 2x, negative 4x, and then plus 2. Okay? Now, hence, find the exact value of the x coordinate of C. So we want to set this equal to 0 because that's the second derivative, and we want the x value of the inflection point. So e to the negative x never is 0, so we just have that quadratic equal to 0. And since they say exact, we know we're going to use quadratic formula. So negative b plus or minus square root, b squared minus 4, a is 1, c is 2 all over 2 times 1. So 4 plus or minus 16 minus 8, which is 8, over 2. And then 8 is 4 times 2, so from the 4 comes out a 2. And then we can do 4 over 2 is 2. 2 over 2 is 1. So we know we want the one further along. So it's going to be x is 2 plus root 2. All right, on the axes below, sketch a curve y equals f of x that satisfies the following conditions. Okay, so from -2 to 0, the derivative is negative. Don't know. So we can do like down, because it's concave up and it goes down. Okay, so now we have at x is 0, so we need to go just like down to here. And then that's a minimum because the gradient's 0 there and it's still concave up. Okay, so then from 0 to 1 it's positive, so we need to go up, and it's still concave up, that's fine. Maybe I need to make that a little, because we need to connect it with that 0.12. Still positive, and that's an inflection point because the second derivative is 0. And from 1 to 2, the gradient's positive, but it's like that, something like that. Okay, I don't know. And that just goes to 2. So 1, 2, yeah. So we just want like that. Okay. Something like that. 21, g at x is that, use quotient rule. So for A, we have g prime, start with x squared, and then we do v times the derivative of u, which is 1 over x, so the derivative of natural log, minus the derivative of v, which is 2x times u. So this is going to simplify to x squared over x is x, and then minus 2x natural log x over x to the 4th. And then we can factor out an x, so that's going to be 1 minus 2 natural log x over x to the 4th, and we can cancel one of those. So that's 1 minus 2 natural log x over x cubed. The graph of g has a maximum at a, find the x coordinate. So we need to set 1 minus 2 natural log x over x cubed, the derivative, equal to 0 to find the maximum. When we multiply by x cubed, we just have 1 minus 2 natural log x is 0. Then we subtract 1 and divide by -2, which is 1 over 2, and write it exponentially. We're going to have e to the 1/2 is x.